welcome back to Dragonfly Engineering. So this week it's going to be some internal moving of equipment and some electrical hookup moving around because we're finally going to move the 25-ton new molding machine into the clean room in here. I bought the Boyd 25-ton about 3/4 of a year ago, and it's been sitting in the hallway, basically still on its rigging skates ever since I bought it. I've just been so busy I haven't had a chance to bring it in here. So with the new gantry crane project that we're kicking off, it really makes sense to go ahead and move that molding machine into the clean room. So I've removed the temporary sliding glass door, so it's not really a clean room in here right now. And I am reshuffling some of the molding machines. So one of the ones that needs to move is the big 90-ton molding machine here. Well, it's actually 90 metric, so 100 US ton. This machine weighs, right now with the extra robot and a mold in it, about 7,000 pounds. So I'm going to show you a technique that hopefully works, Egyptian style moving, and I'm going to jack this molding machine up onto these cross tubes. I'll show you here in a second. And then the steel tubes or beams are sitting on these little 1/8" wall steel pipes as rollers. So hopefully I can just move this machine back. It needs to move back about 7 inches or so. Yeah, I've pretty much almost killed this pallet jack by trying to move this molding machine and other equipment around. So let me try another pump here. I might have to put oil in it. Yeah, it's had a hard life. Okay, so I'm going to measure the length for the conduit that's going to be clamped into the top of this switch box and go into a junction box in the attic. We can clean up the end of our conduit. It's good practice, just so you don't have any sharp edges that'll cut into wire and short out. Okay, so I just ran and got some general hydraulic oil that I use in the molding machines. And I think I'm pretty sure there's like a bladder thing. This guy right here, normally that's full of oil, but it looks like it's run out. I think it just pops off. Oh yeah, like that. Whatever, I forgot the term for this hydraulic oil, but it's general use. So I'm just gonna pour some right in here. Let's go ahead and put the cork back on. Yeah, it sounds like feels like it's pushing the air out of the cylinder. Yeah, so we lifted up pretty good there, I think. I basically bent the entire pallet jack moving this machine last time. And the idea is that we picked up the half of the molding machine with the pallet jack. I put this steel tube under here, and then we've got these pipe nipples, this 3/4 inch pipe, 6 inch, 3/4 inch, galvanized steel pipe. And with enough, I think I got 3 of these pipes under here. So when we lay the molding machine down onto those pipes, as long as they don't bend or turn into oval shapes, then I should be able to roll this machine back with relative ease. Unfortunately, I've got about a 500-pound steel mold loaded in the machine as well. I don't really want to unload that because it's going to be work to put it back in. I did want to spread the load on this little cantilevered toe, or whatever this thing's called. I think it's called a toe jack. I'm going to put this punched out stainless steel 3/8 inch plate on the foot here. And we're not moving it very far, so this should be safe. And then I'm going to stick this whole toe underneath the corner of the molding machine. And I want to distribute the load from that single point across that plate, because this is a hydraulic oil tank, I believe. Or, to put it another way, I don't want to tweak the frame and actually crack a weld and start getting a hydraulic oil leak out of the reservoir. And we will jack this thing up. So here we are, we're starting to lift. And all I'm doing is, now the foot is floating, so you can see the molding machine is lifting, but the foot is just sitting on the ground. So I am going to raise this molding machine up just enough to get our pipe and our little pipes and the steel tube, that is. Still a pretty decent amount of force to lift this guy. That may be enough. Here Okay, so let's give it a try. I may need a 2x4 to get it started. Let's see if I can move. Sometimes getting a resonance going. Yeah, it's wanting to. All right, so I am going to take a picture of our wiring scheme right now. My phone still works. And then I'm going to disconnect these, well, everything in here actually, because I need to shift this box over, because I'm going to plan on putting a second disconnect to the side next to this box. So let's go ahead and start yanking wires. I double checked that the power or the breaker is off, because the power is also off right now. That's why we're doing this up close and personal episode. This flex cable will just be decommissioned or used for some other tool in the future. But for now, just get it out of here after I've documented the polarity. Oh, this screwdriver needs some help. I'll be right back. Okay, I got a screwdriver with an actual blade on the end. Yeah, so like I was saying, in this case, this is three-phase power, so we have to keep track of that the black connects to the black, the red connects to the red, and, well, in this case, the white, which shouldn't actually be a power carrying connection, connects to the blue. If we flip two of these, then the motor may run backwards in the molding machine. Of course, this molding machine is mostly digital controlled, so it may not matter, but it's good practice to keep your polarity correct in three-phase power. Old induction motors that don't have, like, variable frequency drive controls and all that can run backwards if you inadvertently flip two of your three-phase power lines. Okay. So we'll pull all this out. So this conduit is held in by this thin nut here with tines. A lot of times you can tighten this nut down by pushing on the edges with your screwdriver. Kind of just tighten it. Sometimes you can whack your screwdriver with your palm. And then the other side is, so this nut screws down and clamps onto the sheet metal of your box, like so. Okay, let's toss that. And since I'm moving the top over, or the box this direction, this conduit is going to wind up going into the far left hole of the box. And then the outlet that tube I just cut, or the conduit I just cut, is going to exit in this hole. I got some random hardware up here. That's probably when we installed the molding machine about 3/4 of a year ago. This white is a neutral for the three-phase, which isn't used. I brought it just in case in the future I wanted to pull off 120 volts by basically different ways of wiring this three-phase power. It's also good to only have one hand in the box at one time. If you got two hands, then you may actually short your body and run power across your heart, which can stop your heart. So with all the other precautions, it's best just to have only one hand in here at a time. This little plastic cap here that I'm taking off is a abrasion resistant cap. This plastic edge here is an added level of protection for your wires, because here it can kind of rub on this steel and cause problems. So now what I'm going to do is loosen this nut up here, this captive nut for the conduit clamp, and basically get the screwdriver blade onto the tip of this kind of thin nut here, and I hit it with my thumb, or with my palm, and then you can see how it loosened. This is unistrut, and there's nuts that slide into the unistrut, the steel structure, and then these screws are screwed into the unistrut nuts. Kind of a hassle to get these screws back into the nuts. That's why I'm avoiding taking them all out. but it's more of a hassle if you damage your wires. Oh, okay. All right, so we are going to take this guy off. All right, then I can prep the new knockout on the floor. So let me just stick it right under our little board here. All right, here we go. And I'm gonna try to pry the machine back. Yeah, it kind of worked. Let's try that again. It is rolling. There we go. But it's it's chipping off a chunk of wood every time it rolls. Okay. Oh, I should preface all of this with you should hire an electrician to do this kind of work. So don't do what I'm doing. Unless you're a trained electrician. Anyway, so these knockouts here, they kind of make them so you can break out different portions of the panel for the size of the conduit that you're going to run in. And what you do is basically there's some weak welds here that hold all this together. And you basically break off the weld that you don't, or the portion of the hole that you want for your part. And you kind of have to flex these spot welds to break the connection. Yeah, you break it enough so that you can start rocking it back and forth. Ideally with some pliers, like this. And then you just pull out the chunks that you don't want to be in there, and then kind of fix the rest. It's not a load-bearing hole, it's just a hole to keep people's fingers out from getting zapped. There we go. And yeah, we moved about 3/4 of an inch there. So we're just gonna kind of inchworm our way along to get this heavy machine moved back. Here we go. Here I am behind the molding machine, and you can see I'm really giving myself not much room here. And then this door will open so that I can, and you can't probably see it because of the glare of this window, but here is where I work on the back of the mold to tighten the mold hold down clamps and then put heaters in and deal with wiring for heaters and everything. So it's good to have access. It's tight quarters. But I need tight quarters to fit the other machine in, so that's what we're going to deal with. Okay. Last one to go, one on top, which is a lot easier to install before all the wires are strung. There's the airplane flying over. Okay, there we go. So I can't really just disconnect this transformer easily. To push it from the hallway into the back wall where that stainless steel wall is, basically in this space here, I'm gonna have to deal with the fact that that transformer is gonna be basically just constantly a hassle of keeping up and not getting bound up or staying on track. So it's going to be slow going. Anyway, so looking at how this machine is set up to roll, I've got these riggers skates basically, which, let's see if I can zoom in on one. You can see how basically it's got heavy red wheels there. And then the black ring is actually a rotary bearing so that it'll spin. And that one in the back corner is not quite on, so I may have to jack it up and reset that one. But as you're rolling this machine, there's 4 of these skates, and only 3 of them are actually in contact, and the 4th one is always not in contact because 3 points make a plane. So one of these skates is always wanting to lag behind or just stay on the floor and not go with the machine. So you kind of have to push 4 inches and then check the skates, and then push 4 inches and check the skates to make sure that they stay under the feet of the molding machine. I may actually put some cribbing block under the bulk of the machine as well, just in case things get out of hand. It will fall onto the cribbing block as opposed to it just rolling over or falling off the skates and maybe sitting on its side. And we don't want that. So, all that being said, I think the next thing to do here is to just get at it. So I will start pushing this thing. I try to avoid having to drive to the hardware store every 15 minutes doing these kind of projects. So I'm tightening this conduit clamp down, which then passes through our hole, and then our nut screws it on in place. So let's pass this guy through to the attic. I'll attempt to record in the attic, but it may be too hot and dark and nasty up there, so let's see what happens. Okay, here we are up in the nether worlds of the upper attic. Maybe I can rotate around for you. So there's some HVAC, refrigeration lines, HEPA units, a kind of a duct to go into another HEPA unit that's behind there, you can see there. And then lighting units looking into the clean room. But our area of interest right now is over here with this conduit. And we're going to basically put a junction box right there. So we'll see how long I can bear to be up here and record. Okay, let's get at it. So let the misery begin. All right, well, I got it this far, so far so good, even though this is the easiest part, is straight line. So now I need to start kicking the back of the machine that way so I can start turning into the entry to the clean room or the molding room. So they do pivot, which is nice. I may need to get a big old pry bar here though. I don't want to mess the paint up too much on the bottom. You don't really know when the load is going to shift from one skate to the other, so you want both of them kind of optimum so that when they do take up the load, they're ready for it. All right, I'm going to have to brag a little bit about my rigging skills. So the placement of the skates resulted in me cutting this corner right here. So then there's about 1/2 inch or 3/4 inch finger width between the aluminum corner and the actual face of the molding machine. a little bit of a tight fit between the 25-ton molding machine and the white robot here. So we'll see how this goes. Okay, now we're inside the office with the glorious air conditioning running. And I'm going to finish cutting out the clearance holes in this double junction box and couple them together. We're going to couple the two boxes together using this plastic coupler, which is a different standard of electrical. We'll screw together to tie these boxes together and have a burr-free electrical pass-through between the two boxes. So this is a Greenlee Punch, and I don't know if I'm sure some of you are familiar with it, but basically it's a two-part system where there's the cutter die and then the corresponding female mandrel part, and all of that is backed up with this thrust bearing. So what you do is you stick the cutting die in there. I guess we'll offset it a little bit in an existing hole in your electrical box. This could be your circuit breaker box, a transformer housing, or a junction box like this one. What I'm doing is I'm screwing the two together, and we're creating a hole punch scenario. Now all we do is we tighten down the screw here on the outside, or the hex head, and we're basically going to draw this punch inward into the female portion of the hole puncher and cut out the sheet metal section in this box. So it's a little meticulous, or it takes some, not meticulous, but it takes a while to do. Let's make sure you can see the action. And that felt like the other one broke through. Okay, and then there's our punched hole. Whoop, you see that hole there? So that will work with the 1-inch conduit coupler that we have. So I got a few more of these to do. So I'm not going to run wire through here, but I'm going to run it through this protected plastic collar. I think we are ready to go back into the hellfire of the attic. So I'll meet you back up there. So these punches are nice because you can kind of just use them anywhere in the field, as long as you got wrench access. All right, we are at the final stretch. A couple of minor close calls, but now I got the pallet jack under there, so it should be pretty safe. And we'll go ahead and nudge this machine into its final position. So for now, until I fine-tune basically the fitment of the molding machine nestling into this molding machine and the fitment of the back of this molding machine dealing with the gate on the big molding machine, I'm going to leave the little molding machine on its trucks here for a day or so once I get everything going. And then I can bring the pallet jack back in and actually set this molding machine on its levelers, and then it'll be permanently placed. I've been running this machine for about half a year on these trucks anyway, so it's not a big deal, even though I am in earthquake country. So I'll have to be a little careful with that. Anyway, so I got the machine in there, and I'm going to hook the power up over there in the corner, bottom left, and get this guy cranking out parts again. Okay, we're done. Got the machine in here, got everything hooked up. All three machines ran simultaneously without blowing the breaker for the building, the electrical breaker, so that's good. I've also got temperature controller running, a static electricity eliminator. It's like an ion blower, which I'll show you here in a second. We can walk around and I'll show you some of this stuff. So over here is the one that I'm going to show you how we're going to make. Again, I can't show you some of these parts, but this one we can. So this guy, and the large molding machine is about to run out of plastic, so that's why we're kind of running it here. But yeah, you can see how we're cranking away. Let's see this guy open. I did work out some of the spacing, but I've got a little more to do. So there we're ejecting, and we'll close again. That's the big part, ejecting over there. An interesting tidbit here is this is a Esd Eliminator. So up inside of those holes is a bunch of little steel needles that are at 4,000 volts. And it's creating a flow of ions, which eliminates static electricity in plastic parts. So you can see down there, that's our bowl of parts. And I'm blowing that static electricity eliminator on it to keep these parts clean. Because as you saw, I'm in my bunny suit here because some of these parts need the specification is to be clean room parts. So there it goes, ejecting again. Over here is the 40-ton molding machine. So this particular mold, I'm going to program the orange robot here to pluck parts out and do additional work, and then ultimately hand it over to the white robot over here to do some ultrasonic welding. I'm going to go ahead and probably turn off the big molding machine, so I'll be right back. So this is a temperature controller that my dad and I worked on. This used to be an old stereo system, and we gutted out the stereo and then put all these temperature controllers that we got on Amazon in there. So all of these molds need to be heated. Basically all these heaters are heating different molds or heating bands for the various molds in this room right now. My brother actually made another one of these, which we'll show. he machined the front panel and did the sheet metal to basically recreate another one of these. Because I'm running out of heaters, as you can see. All of these are running right now. Anyway, so that's the integrated homemade heater system for the molds. Well, that's it for this week. Thanks for watching, and I'll see you next week. Probably with either more gantry crane work in this room, now that we know where the legs can go, or I may show you how we built that mold that's running right now in the 25-ton molding machine. Thanks for watching. Oh, one last thing. I started a Patreon page for Dragonfly Engineering. The main reason for that is a lot of times I can't really show you the work I do here because it's for daytime customers, hence this plastic bag over the molding machine window here. So I'd like to be able to do more products that I can sell directly to viewers or on Amazon that are not related to my day customers. And to do that, the Patreon page would help with funding to do our own projects that we can basically do and show and share. So I'd appreciate it if you're interested in the work I'm doing here. And if you'd like to see like products developed from design to manufacturing that ultimately if you'd like to buy, then please check out my Patreon page and you can donate some cash and I'll reinvest that back into projects that we can do on the show that everyone can see. So check it out. Details are going to be below, and I look forward to doing more shows and more interesting projects that I can share with you. Thanks.